Today in this video, I'm going to show you how to do the degree of freedom coupling in Abaqus. Actually, coupling is kind of constraint. Actually, it's a very useful technique. So it's like you can glue a point on the model, and then you can apply the, the load displacement directly on that point. Why? Because this point is glued somewhere. So it's it's it has been glued firmly with the model. So then you can load the point. So and this technique has many advantages. So for example, um, quite often we want to know the reaction force um, at a certain point of your model. So with the with the coupling of uh, point on, on your model, so we can easily know the reaction force on certain point. So now I'm going to show you how to use the coupling in Abaqus. So first we need to open Abaqus here. Yes, open Abaqus. Okay, because I have already a model called beam, so we can directly input this model. So to do the coupling, what we need to do, what we need to do. So in this example, I want to glue a point on this surface. So I want and I want to apply load directly on that point. So I want this surface moves together with the point. Okay, so and then we need the coupling. So or we can do the coupling. So first we need a surface, then we need a point. Then we do the coupling between the surface and the point. So first we need to create the surface. Okay, so we can call it the surface point because this is a mesh model, so we have the type of the mesh. Okay, continue. I want to select all the surface on this big surface. So of course I can do it individually, but very boring. So but we have a good technique is called selection by angle. So if you do the selection by angle, just what you need to do is just move your mouse here, then you can select all the surface. Then either click middle button of your mouse or either click then you have uh, create the surface. So you can verify. Okay, then we need a point, right? So the coupling point is for the coupling point we need the reference point. So here we can create a reference in the middle of this model. So then you will have RP1, which means reference point. So and we need a set. So we are going to rename this reference point to as a LP, which means load point. And continue. You can select this one, and then you can verify. Okay, so have a set. You have a point. Okay, so now we go to constraint. Constraint here we can choose coupling and continue. So here Abacus asks you to choose a type of region. So here yes, because first we need to choose the coupling point. So here we can no, no. First Abacus asks us to choose the coupling surface. So because I think we have already the surface. Surface is a geometry, so here we choose geometry. Sorry, mesh. Okay, here Abacus. Sorry, I will say it again. So Abacus us to choose first choose the coupling point. So here we do geometry, or here we choose set. We choose the coupling point. So you can highlight to verify if the coupling point is okay. Then you click continue. Then Abaqus asks us which surface we want to glue this point on. So here this time we choose surface. Then we can choose the surface we have created before. Then you can do continue. And here you have many degrees of freedom because this model is a 3D solid element model, so we don't have we don't have the rotation on the node, so we can just unselect this one. So here make sure you have the kinematic coupling, and just keep the U1, U2, U3 be selected, then click OK. So when you have finished that, so you will see the point is glued on this surface, and then you have something like that. So now we are going to apply some load on this reference point. Here, no, we are going to, this time we are going to apply the displacement on this point. So we double click DC, and here we can rename it the and here we choose displacement, continue. We are going to apply the displacement on the load point and continue. This time we are going to load this beam in y direction, okay, in this direction. So we choose 10 or whatever. You can choose 20, okay, no problem. So this time we choose okay. Then okay, so you will see that. So now you are going to load your model in this direction. Okay, so we can edit the load step from that, and we are going to create a job. So because here we have already input file which is called beam. So here we are going to create a new file. It's called beam new. Okay, continue. Okay, then you can try to write the input. Okay, so when you write the input, you have a beam new. Okay, then submit the job. Okay, because job file already exists for being new. Okay, don't worry, because each time you submit the job, Abacus will write input first. Okay, so don't worry, submit. So let's check it's running. So we are going to monitor the result. Okay, that's nice. Complete. So let's check the result. Okay, we do the deformation, we do the animation. Here you can choose uh, some technique to visualize your model. Okay. Okay. So that's the technique of coupling. So you don't need to apply complicate displacement on this surface. What you need to do is just make a coupling and glue some point on this surface and then load that point. That's all. Okay, now I'm going to continue to introduce why we need the coupling. So yes, for sure, it, it's simpler to apply some load on the model, but there is another reason for the coupling. So for example, one if you have the deformation of the beam, so if you want to know the reaction force on that point, what you need to what you need to do. If you do the copying to calculate the reaction force, will be very complicated. Will be very complicated. So with the coupling with the reference point, you can easily output. You can easily know the reaction force. So now I'm going to show you. Okay, how to know the reaction force by the coupling on the load point. So because here this is our load step. So here we choose the history output. We can double click that. Okay, we created. We can create each output two. Okay, continue. Here we can choose set. We can choose our load point. Okay, on this load point, what we want to output? We want to output the translation displacement, and also we want first the reaction first. Okay. So here we have create created the new output to output the displacement and reaction force on this point. So we will run again. Okay, let's check the result. And here you can have, yes, you can find the reaction force in x direction. For sure is zero because we have loaded the model in y direction, which is r reaction force 2. Yes, okay, so you can see the yielding of this beam because I have applied elasto plastic material for the beam. For the reaction force 3, 0 of course. We have also output the displacement. Okay, for sure the displacement in x direction is 0. Okay, so here we can see we have loaded the beam in y direction, so with the 10. Okay, so then we have our displacement, and the u3 is 0. Okay, and let's try to modify. Yes, that's okay. So let's try to modify the direction of loading of this model. Okay, so this time we are not going to do it by Abaqus CAE because we have already our model, right? So we can load it. We can directly modify this input. Okay, I can show you. This save change to the model. No, we don't need that. So this is our model. Okay, here at the end we have our loading step. Okay, so this because we have loaded the beam in y direction, so that's why we have two here. So imagine if you change the direction like 1 1, so it means this time we are going to load the beam in x direction. Okay, so model, yes, we have saved the model. Yes, yes, we are in the good folder. So after CAE, we are going to submit this job. Beam new. Okay. And do you want to overwrite the old file? Yes. So then Abaqus is running. Okay, the simulation is finished. We can open up the CAE again to check the result. Okay, result open our module. Okay, then check the reaction. Oh, no, first check the yes, check the business information because this time we have loaded the file in uh, in extract. Oh, then the information is like that. Then we check the displacement. Yes, this time we have a U1 with 10. Okay, and for sure this time we should have the RF1, which means reaction force. Yes, okay. So we have a curve like that. So why the values is uh, is 30,000. Okay, do you know why? Why the ultimate force for this beam is 40,000? Okay. Oh, I'm going to tell you because here, yeah, sorry, because here let's check. Let's check the section of the beam. Okay, it's 10 by 10. Okay, so and let's check the material. The material for the beam is elastoplastic beam. Okay, the yield stress is 400. Okay, so let's do a simple calculation. So we can use the Python environment in Abaqus here. So the section area is 10 by 10, and if the yield stress is 400, then 10 by 10 minus the stress will give us the force, right? Okay, so that's why we have 40,000 for the reaction force, right? And this value is exactly the same as what you have here, right? Okay, that's very nice. So in this way, we can easily know the reaction force of the model.